Hello everyone and welcome to Infotainment Lounge. This stream is for O-level and IGCSE students, and this is about the addition polymers. So before starting, if you can see me, if you are there, please say something in the comment section so that I may know that I'm live. Okay, so guys and girls, today's video is about addition polymers. So first of all, we need to understand a few terms. One term is macromolecules. See, what are macromolecules? This term macro means huge. So macromolecules are huge molecules. They are made up of many atoms. How many atoms? They may be made up of hundreds of atoms or thousands of atoms or even maybe millions of atoms. So these huge molecules are called macromolecules. Now there is a term polymer. See, polymers are a type of macromolecules. See, macromolecules could be huge molecules which contain many atoms, but the atoms in the macromolecules may have a specific sequence or not. In case they are those macromolecules are made up of specific sequences of sets of atoms, then they are called polymers. I would try to explain it a little more in the way, like, if there are many small molecules, those small molecules may be of same type or different type. When we are talking about addition polymers, we are talking about same small molecules. See, if those same small molecules keep on linking up together to form a very long chain, that long chain formed by the linking of many small molecules is called a polymer. And those small molecules which linked up together to form a polymer, those small molecules are called monomers. So first note down these two definitions. And the reaction in which many monomers link up together to form a polymer, that reaction is called polymerization. Now there are two types of polymers. Addition polymers and condensation polymers. These are the two main types of polymers, and in today's video I am gonna go into the details of addition polymers. I'll make a separate video, I'll give a separate stream hopefully tomorrow on the condensation polymers. I will let you know the timetable for the next stream. So note this down, then I'll move on to the next window. Okay, now addition polymers. What are addition polymers? Addition polymers are the polymers which are formed by addition reaction. Now if you remember what addition reaction is, as you have already studied that in the reactions of alkenes. See, addition reaction is a reaction in which molecules are added to each other without the formation of any byproducts. That is the definition of an addition reaction. So in this case, in addition polymerization, a polymer is going to be formed by the addition of many monomers and no byproduct will be formed during the reaction. Okay, so if you are an O-level and IGCSE student, there is only one such homologous series in your syllabus in which addition reaction is possible, and that homologous series is alkenes. That means the presence of a carbon to carbon double bond. So in order to undergo addition polymerization, again the monomers have to have carbon to carbon double bonds. That means they have to be unsaturated compounds. It is possible only in the compounds with carbon to carbon double bonds. And all the monomers in a polymer, in a single polymer, all the monomers will be of the same type. See, this statement that all the monomers in an addition polymer are of the same type, this statement is valid only for O-level and IGCSE students, not for the students who are studying in higher classes, because addition polymers may have different monomers in them. But for O-level and IGCSE syllabus, all addition polymers will have only the same type of monomers. The student has asked that when I going to go in multiplication polymers. There is no such thing as multiplication polymer. These are addition polymers or condensation polymers. Those are only two types in your syllabus. I suppose that was a joke, but anyways. Okay, now let us first, another thing you need to know is how to name addition polymers. There is a very simple way of naming addition polymers. You just put a poly behind the name of the monomer. For example, if the monomer is ethene, if ethene is the monomer, then polymer would be polyethene. Simply a poly behind the name of the monomer. This would be the name of the polymer. This is how addition polymers are named. Suppose we are talking about 2-methyl-butene. This is the name of the monomer. If this is the name of the monomer, the name of the polymer would be poly 2-methyl-butene. So this is how we name addition polymers. Now let us even if you have the name of the polymer and you have to tell the name of the monomer, they have given you the name of the polymer, which is polyethene. Just remove that poly. The remaining part will be the name of the monomer. Ethene would be the name of the monomer. So how to construct the structures of these addition polymers? I will start with an example of polypropene. See, this is the name of the polymer, polypropene. So what would be the name of the monomer? Monomer would be propene. So let us draw the structural formula of propene. This is the structural formula of propene and this is the monomer, and we know that the reaction taking place is a polymerization. Poly means many. That means many such monomers are going to link up together to form one long chain. So we have to write an N behind this. This N means there are N number of propene molecules taking part in this reaction. That N could be any large number. It could be 100, it could be 1,000, it could be 10,000, any large number. So those many propene molecules are going to link up together by an addition reaction. And how does addition reaction take place? One of these two bonds, out of the double bond, one of these bonds is going to be broken and there would be single bonds between these carbon atoms now. Okay, now first we have to break one of these two bonds. The remaining bond will be a single bond between these two carbon atoms. Now let us take a look at what are the radicals bonded to each of the carbon atom. Like this carbon atom is bonded to two hydrogen atoms. Now you have to be very careful by putting these radicals. Do not put any radical on the left side or the right side of these atoms. Arrange everything above and below these carbon atoms. Like if there are two hydrogen atoms bonded to this carbon atoms, one of them would be placed at the top and the other one at the bottom. Now let us take a look at the other carbon atom involved in a double bond. To one of its sides there is a hydrogen atom, so I can arrange the hydrogen atom at the top. To the other side there is a methyl group CH3, so this entire CH3 would be shifted towards the bottom. If you place this hydrogen at the bottom and place the methyl at the top, that won't make any difference. You can do that. That is completely normal. That is completely correct. But you cannot place this CH3 right here on the right side of the molecule. You cannot do that. And you cannot place this hydrogen on the left side of this carbon atom. That is not allowed when you are constructing the structures of polymers. Okay, so this part is coming from one monomer. So this part is one repeat unit of the polymer. This unit will keep on repeating itself. See, there are many molecules like this. So there would be many units formed like this. There would be another unit right in front of it. Now look at this carbon atom. Carbon always forms 4 bonds, but this carbon atom has formed 3 bonds only. So there is one valency vacant in this carbon atom. So is the case with this carbon atom. It has one valency vacant. So they will form a single bond with each other. Similarly, there will be a similar structure behind this unit. It will form a bond with that one. That means this structure is continued on the left side, and this structure will have another similar structure on the right side of the molecule, and it will form a bond with that structure in front of it. So this would be continued on the right side too. And how many times it is going to be repeated? For a number of times. It could be 100, it could be 1000, it could be 10,000, whatever the number is. So this part, see, the part coming from one monomer is called one repeat unit. So the structure, it is not a complete structure of the polymer, it is just a part of the polymer. And this part of the polymer contains 2 repeat units. So this structure that I have drawn is the structure of polypropene. And I have shown 2 repeat units. Of polypropene. If I had to draw the structure of one repeat unit only, then I would have done it like this. Continued on both sides. This is one repeat unit. It is still polypropene, but it is one repeat unit. If I was to draw 3 repeat units of polypropene, I would have drawn another similar structure in front of the next one and showed the bonding between these two and between all 3 of them, and that would have been 3 repeat units. So you could be asked in your examination to draw specific number of repeat units of a polymer's structure. There's a question that there are 2 questions actually. One of them is that if they say to make 3 repeat units, will we make those brackets or not? See, those brackets are not actually compulsory. If you give the structure without these brackets like this, even then it is fine. And even if you don't write this N, this structure of polymer is fine. But you have to show the continuation. This bond is a must on each side. This longer line for a specific bond which shows the continuation of the chain. It is a must, irrelevant of the number of repeat units. Whether you are drawing 2 repeat units, 1 repeat unit or 18 repeat units, you have to show the continuation sign, and this bond shows the continuation side. It is often supported by these brackets. But even if you forget to draw the brackets in your examination, you will still get the marks. Okay, another question is that is there any condition for this reaction? Yes, there are actually conditions for. In fact, I want you all to note this down that. So yes, this reaction takes place when the monomers are heated together at a high pressure in the presence of a catalyst. You don't need to know the exact temperature, you don't need to know the exact pressure, and you don't need to know which catalyst is used in these reactions. So you just need to remember that a high temperature, a high pressure, and a catalyst is necessary. These conditions are necessary for polymerization reaction to take place. That is all you need to remember. Okay, so guys, I'll give you another example. Like if we have if they have asked us to draw the structure of polybutene. Now that means the monomer is butene. So first let us draw the structure of butene. This is the structure of butene, which is the monomer. And there would be n number of butene molecules involved in the reaction. Now, again, it is an addition reaction, so one of these bonds would be broken and the carbon atoms will have a single bond with each other. These carbon atoms, which initially had a double bond with each other, now they have a single bond with each other. Now look at the radicals bonded to each carbon atom very carefully. First, to the carbon atom at the left, it has one hydrogen, so one hydrogen at the top, and the other radical is a methyl group, a whole CH3 group. I cannot write that CH3 group on the left side of this carbon atom. I will have to draw it at the bottom. Again, it doesn't matter bottom or top, but you cannot draw any of these radicals on either left or the right side of the carbon atom when you are constructing the structure of a polymer. Okay, now let us take a look at the next carbon atom, the carbon atom involved in the double bond. This has hydrogen on one side. I'll draw the hydrogen at the bottom this time, and the other side is bonded to a methyl group, CH3 group. That whole methyl group would be shifted to the top like this. So this part is coming from one monomer, so that means it is one repeat unit. Suppose they asked us to draw one repeat unit only, so we will show continuation signs on both sides. That means this will be repeated for n number of times, and this is the structure of polybutene, and this is its one repeat unit. Another difference that you must have observed by now, that these monomers had carbon to carbon double bonds in them. That means they were unsaturated compounds. But these polymers, in polymers all of the bonds are single bonds. That means they are saturated compounds. So even the polymers formed even by the combination of unsaturated monomers, those polymers are still saturated. So this is unsaturated and the polymer is saturated. Okay, we have a question that are there no specific polymers that we need to remember? Will examiner give us any random polymer to make? See, in order to make the structure of a polymer, yes, he can give you any random polymer. He can just name a monomer, a random monomer, and you will have to draw the structure. Uses of some specific polymers are there in your syllabus, and you will have to learn them. In today's class, I am going to describe you the properties and uses of some specific important addition polymers. Okay, somebody has asked me to explain this again. Okay, I'm explaining this again. See, this is polybutene. They asked us to draw one repeat unit of this polymer. Now, first, by observing the name of the polymer, I analyzed the name of its monomer. I just removed the term poly. The remaining part was butene. That is the name of its monomer. So, first I drew the structure of butene, which is a monomer. Now, there are n number of molecules which are going to react together to form a very long chain known as polybutene. So, this is n number of butene molecules, and they are going to undergo an addition reaction. And how does an addition reaction take place? It always takes place in the same manner. One of the bonds in the double bond is broken. So I broke one of the bonds, and the two carbon atoms which were initially involved in a double bond, they are now bonding to each other with a single bond. Now the radicals which are bonded to these two carbon atoms, like the carbon atom on the left, it is bonded to hydrogen from one side and it is bonded to a methyl group on the other side. I have to arrange these two radicals above and below that carbon atom. I cannot place anything on the left or the right of these carbon atoms. So I arranged hydrogen at the top and methyl at the bottom. Now let us take a look at the other carbon atom involved in the double bond. This one is hydrogen and the other one is the methyl group. This carbon atom is bonded to one hydrogen and one methyl group. Again, these two radicals have to be shifted above and below that carbon atom. I cannot place any of these on the right side of this atom because that would end the chain. I would not be able to show the continuation sign. So they have to be arranged above and below. So this methyl, I have arranged this methyl at the top and hydrogen at the bottom. It doesn't matter if you have arranged hydrogen at the top and methyl at the bottom, that is the same thing. But don't place anything onto the right or the left of these carbon atoms. So this part of the long chain, see, this chain is continued from both sides for n number of times. But this part of the chain is coming from one monomer only. One monomer had 4 carbon atoms and 8 hydrogen atoms, and this part has 4 carbon atoms and 8 hydrogen atoms. That means this part is coming from one monomer only, and that part is called one repeat unit. So this is the structure of polybutene, but this is just a part of that long chain, and this part represents one repeat unit. That means this unit is going to be repeated over and over again for many times. And this is an unsaturated compound because of presence of the double bond, and this is a saturated compound because all bonds are single bonds. You have a question that if we have broken the double bond, doesn't that mean they are alkanes now? Yes, that is what I have been telling you, beta. This is a saturated compound. This has all carbon to carbon single bond. But this is a polymer. You don't have to name it the way you name normal alkanes. This is a polymer. So the naming would be according to the naming rules of polymers. And how to name addition polymers? Just put a poly behind the name of the monomer. The monomer was butene, so we just added a poly behind that. So polybutene is the name of this polymer, although it is not an alkene anymore. It's an alkane. It has all the carbon to carbon single bonds. It does not have a double bond. I hope you get it. Okay, now what I am going to do is that I am going to write the names of a few polymers and I would like you to try their structures by yourselves. Apply the same technique. First, find out the name of the monomer, then draw the structure of the monomer, then use that structure of the monomer to construct the structure of the polymer. So I will give you a few names like okay, guys and girls, I want you all to draw the following structures. You may use the structures of monomers and you may show them in a reaction form, but it is not compulsory. What I need to see is the structures of these polymers. Like polyethene, you have to show 2 repeat units. Polybute 1-ene, 1 repeat unit. Then polychloroethene, 3 repeat units. Try making this yourselves. I will give you a few minutes. You have 3.5 minutes to solve this question. Then I will come back and tell you the answers. Guys and girls, hurry up please. In 1 minute I am going to tell you the answers. Okay, now I'm going to go for the answers. Polyethene, 2 repeat units. This is the structure. Polybute 1-ene, 1 repeat unit. This is the structure. And polychloroethene, 3 repeat units. This is the structure. Check your answers, and if you have any questions, you can ask me now. I'm assuming there are no questions, so I'm moving on. Now there are some specific addition polymers which you have to remember. They are a part of your syllabus. I'll mention those. Okay, now a very common polymer is polyethylene. And the polyethylene is, the monomer of this polymer is obviously ethene. The common name of this polymer is polythene. Have you ever heard the term polythene? See, you must have heard the term polythene bags. These are the normal plastic bags. So that is one of the uses of polyethylene. But before going into that, there are two types of polyethylenes. One is high density polyethylene and one is low density polyethylene. The polyethylene which is used to make plastic bags is low density polyethylene. Then which one is the high density polyethylene? The plastic which is used to make dustbins and water bottles, etc. That plastic which is flexible but still it is hard. It is not as soft as a plastic bag, it is hard, but it is still flexible. That plastic is high density polyethylene. Now, when we polymerize propene, we know the polymer formed is polypropene, and this is the chemical name of it. The common name is propane. I know neither of its common name or the actual name is very popular, but still this plastic is very common. This plastic is very common. All of you have seen it. All of you are using it. Even currently many of you are using it because the relatively harder plastic that you see around, like the plastic which is like your calculators are made up of a specific plastic which is harder than those of water bottles or that of dustbins. That is polypropene. Similarly, the plastic used to make the pens that you use, that is also polypropene. The plastic used to make the plastic kitchen stuff like the plates and cups made up of plastic, that is all polypropylene. Another common polymer, commonly used polymer, addition polymer, is polychloroethene. So obviously the name of the monomer is chloroethene. Now the common name is polyvinyl chloride. Again, polychloroethene, this term is not very common. You must not have heard of it. Polyvinyl chloride too is not a very common term. But the abbreviation of polyvinyl chloride, you must have heard about that. It is PVC. You must have heard about the PVC pipings. See, PVC is a thicker plastic than the previous ones, and it is a completely waterproof material. So all the plastic pipes, the water pipes which are made up of plastic, they are made up of PVC. That plastic is PVC. And the water tanks that you see on the rooftops, there are two types of such tanks. Some of them are cemented and the other ones are made up of plastic. That plastic is PVC, polyvinyl chloride. Okay, then there is another one known as polytetrafluoroethene. The name of the monomer is obviously, and its common name is Teflon. You must have heard this term, Teflon. There are different type of utensils in your kitchen even right now. Some of them, the utensils that are used for cooking, some of them are non-stick. The cooking stuff does not stick on the surface of that utensil. That non-stick part of those non-stick pans is made up of Teflon. Okay, another common polymer is polyphenylethene. Obviously, the name of the monomer would be phenylethene, and its common name is polystyrene. You also know this polymer with the name styrofoam. You must have seen that. This is that white material present in the packaging stuff. If you open a new box of electronics, there is one white packing material which comes out of it first, and the electronic thing is present inside that white packing material. That white packing material acts like a shock absorber because of its soft nature. It is a soft solid. That material is actually polystyrene. It is polyphenylethene. And I know you are not familiar with this term phenyl. You don't know what phenyl is. You don't need to go into the detail of what phenyl is. You just need to remember it is C6H5. It is a radical with 6 carbon atoms and 5 hydrogen atoms, and when this is bonded to the 2 carbon atoms of ethene, to one of the carbon atoms from ethene, that would be phenylethene. So sorry, I should have drawn it here. See, phenyl means C6H5, so phenylethene would be like this. And polyphenylethene, this would be the repeat unit of polyphenylethene. This is the repeat unit of polyphenylethene, and it is used as a packing material. These addition polymers are also called plastics. These are all plastics. I'll give you a few seconds to note this down, then I will move ahead. Okay, now these plastics, the addition polymers that we have studied today, they are very easy to manufacture, so they are not very expensive at all, and they can be obtained with the properties, very many different desired properties. So these are the advantages of these plastics, but still there are some disadvantages. There are some problems associated with these plastics. Most of the plastics which are formed by addition polymerization, they are non-biodegradable. See, what do we mean by non-biodegradable? That means they cannot be decomposed by living organisms. Addition polymers are non-biodegradable, which means they are not decomposed by living organisms. Okay, so now we are using plastics, but they are non-biodegradable. What do we do when we use the plastics? We throw them out, and that becomes a part of the regular garbage. And when that garbage is dumped into some place, that keeps on occupying the land, because plastics are not decomposable, they are non-biodegradable. The other material present in that garbage is decomposed by microorganisms like bacteria, like fungi. They are decomposed by that, but these plastics are non-biodegradable, so they are not broken down, they do not decompose, so they keep on occupying the land. So first problem caused by these plastics is the shortage of land. They keep on occupying the land. So when they keep on occupying the land and they occupy the land too much, we have only one option left. We burn them off. We put them in fire. I mean, we burn them off. But there is another problem when we burn them, because the combustion reaction of these plastics, they produce pollutant gases like carbon monoxide, like some oxides of sulfur or even nitrogen. So those problems are associated with non-biodegradable plastics. That means all of these. This is why they are not very environment friendly to use. So they are not recommended, especially the people like you and myself. We know a little bit of science, so we know the reason behind this, that why we shouldn't be using plastic bags specifically. That is the most commonly used form of plastic, and that is a non-biodegradable plastic. So it is our moral responsibility that we should not support the use of plastic bags. Instead, we should use paper bags. Paper is a degradable material, it is a biodegradable material, so we should use paper bags instead of plastic bags. Okay, so this was all about the addition polymers. In my next video, hopefully tomorrow, I will explain addition polymers and their types, and what specific types of condensation polymers are there and how they are formed, what type of reaction is involved. That will be explained in tomorrow's video, hopefully. If you have any questions related to today's stream, you can ask me now. I'll give you a few minutes. If you have few questions, you can ask me. So I suppose there are no more questions, but there is still some learning stuff in this today's topic. So I would advise you all to learn that stuff, and you must know how to construct the structures. You must know the technique to construct the structures of polymers, addition polymers, because they may ask you to draw the structure of any random polymer. So guys and girls, I hope this video was helpful. Keep on watching Infotainment Lounge. I'll see you in the next live stream, hopefully tomorrow. Thank you. Allah Hafiz.